Hi, I'm Paul Greenhalgh, Director of Design at Team Consulting. In this presentation, I'm going to explore what to consider when developing a connected device. I'm going to focus on three key areas. I'll describe a framework we've developed to define needs at the start of a program. I'll share some learnings on the challenges of integrated sensing and connectivity, and I'll discuss the importance of user experience design, ensuring that we consider the motivation and ability of end users. Along the way, I'll pull out a number of questions that you might find useful before embarking on a connected development. Asking whether to go connected might be the wrong starting point. That's a solution looking for a problem. Instead, maybe we should be asking, what's the problem we're trying to solve? What are our commercial needs and what are the needs of our users? And these two things might not be the same. I'll come on to the importance of that later. In our industry, there are multiple stakeholders with very different needs, so it's complicated. So how do we ensure that we're solving real needs with the products that we develop and whether a connected solution is the right strategy? When embarking on a new device development, we found it helpful to map needs and solutions at the start of the program. We found that 5 categories catch most needs: competence, adherence support, disease self-management, patient engagement, and clinical trial support and differentiation. Any or all of these needs might be addressed by a connected solution, but to understand if going connected is the right strategy, we should explore the full solution space, considering non-sensing solutions, non-connected smart devices, and fully connected solutions. By mapping solutions against needs, it helps us to see more clearly where a connected solution is the best or only option, or whether other simpler solutions might be more appropriate. For example, could a simple redesign of the packaging and instructions help with competence by improving the onboarding experience of a new device? Could we support adherence with a simple onboard display which records when the device was last used? Or do we need a more sophisticated solution where usage data is shared with an HCP via the cloud, allowing a targeted intervention if no activity is detected? Any or all of these solutions could be viable, and the most suitable would depend upon attitude to risk, cost, technical and commercial constraints, and ultimately what's going to achieve the best patient outcome. Plotting on a matrix like this helps to ensure that we've explored the full solution space and stands as a good reminder later in the program of what we're trying to achieve so that we avoid scope creep. So let's assume we've decided that a connected solution is the right way forward. Our next challenge then is to integrate sensing and comms into our device. And that's not trivial, particularly if you're retrofitting it into an existing device architecture. You need to think about where the components will fit, how you'll wake the device, what's your power budget and what battery you'll need, how you'll attach the sensing module, and most importantly, you'll need to prove that your tech can provide reliable results when used in a real-world environment. So what is sensing really telling us? Well, it's important to acknowledge that what we're sensing is unlikely to be the actual event that we want to confirm. Assuming that what we really want to know is that drug has entered the bloodstream and it's unlikely that we're going to be putting sensors into the body, the best therefore that we can hope is to infer that the user has taken a dose. And to be confident that we're getting an accurate result, we may need to sense more than one event. So let's look at a capsule inhaler as an example. We might need to sense 2 to 3 events undertaken in sequence to feel confident a dose has been administered. For example, that the mouthpiece cover has been opened, the capsule was present, and that a button was pressed. For each event that we sense, we get a higher level of confidence in our result, but we also increase cost, complexity, and ultimately our power budget. So it's a balancing act. The trick is to find the smallest number of sensors that give us a reliable result and not to get carried away with adding sensors just because we can. So first we'll need to consider how to wake the device. The most straightforward way is with a contact sensor, for example, a switch that is activated when the mouthpiece cover is opened. But there might not be room where the sensor is needed, in which case we might need to look at a non-contact sensor like listening for a click, sensing motion, or performing a visual check. If this is the case, it's likely to have an effect on our power budget. We'll need to listen continually for an event to wake the device. It will also increase the chance of false events. So if possible, a contact sensor is always the best choice. Power budget is a consideration which is likely to have a significant effect on your device design. The battery is going to be the probably going to be the biggest component on your PCB, and it's going to influence where you can fit the electronics module. So going for a big battery probably isn't an option, and changing or charging batteries is going to complicate the user experience. So keeping power budget to a minimum is very important. As a general rule of thumb, if we include 3 sensors, such as a switch to detect cap opening, a temperature sensor, an accelerometer to detect motion, assuming approximately 5 minutes use per day, it gives us the following battery life. If we use a non-contact sensor to weight the device, it's going to halve that. Next consideration is how to fit the module. Essentially, we've got 2 options, factory fitted or fitted by the user. And cost is no doubt going to play an important part in this decision. A PCB with 2 to 3 sensors and a Bluetooth module could cost in the region of $2 to $5. So it's going to add significant cost to a disposable device. Temptation then is to have a reusable module which is refitted by the user each time they receive a new device. But this means we've got to consider what will motivate our users to do so. If the connected add-on increases the size and weight of the device, users may not see the benefit, especially if the device can still function okay without it. Before we get too excited about what our new connected device can tell us, we need to prove that we can get reliable results. And getting sensors to work on the bench is one thing. Getting good results in normal usage conditions is something quite different. So I cannot overstate the value in moving to prototypes early. Good news though, the time and cost to develop quick and dirty prototypes has been significantly reduced by the availability of off-the-shelf dev kits like these from Nordic, ST and Texas Instruments. For just a few dollars, you can measure sound, temperature, orientation, humidity. They come paired with a comms module that allows data transfer to an app, and they're great for a first look-see, but they're quite big and chunky, and they're unlikely to fit within the architecture of your device. So pretty soon you're going to need to spin a custom board like this one, which we created on a recent project. It took around 12 weeks to design, manufacture and bug fix, and it cost around £5,000 for 20 boards. So it's not a huge investment, and it means that you can hack this into a prototype, put it in the hands of users, and start to get a real feel for what the challenges are going to be under real world usage conditions. Which brings me on to the final part of my presentation. How well will your device perform when put in the hands of real people? Just because your new connected device gathers data which could improve our users' health doesn't mean it will be enough to motivate them. They'll probably require something more. And this is where we can learn valuable lessons from our friends in the consumer tech world. What do these guys do to engage us with their products? What makes it easy for us to onboard and very difficult to leave? Well, it takes more than carefully crafted interfaces. We need to consider the positive effect of behavior design. The Fogg behavior model states that a behavior will only happen when 3 elements occur simultaneously. People have to be sufficiently motivated to change their behavior. They must have the ability to complete the task required, and they need to be prompted. So let's look at motivation. What might users perceive as useful? Well, these could be things like technique training during early onboarding, enhanced feedback to increase confidence, or reminders if our user appears to have forgotten a dose. Focusing on delivering tangible benefit to the user is important if we're asking them to do work. The addition of a mobile app gives us the opportunity to provide interventions when they're most useful. We can provide triggers to draw the user into the app, like the red dots that we see on the tiles of our home screens. Once in the app, we can start layering in other useful information to engage them with the therapy, providing feedback, helpful tips on device use, introducing feed from the community, for example. Having our app accessible alongside other apps can help us to build positive habits. The user becomes used to checking their therapy app at the same time they check their other daily feeds, gradually becoming an automatic behavior and reducing the need for external triggers. It's important that the new connected device is integrated seamlessly into our users' normal routine. We don't want to have to change the way they do things. We need to consider their ability to perform the tasks that we're asking of them. When describing ability, or the action of completing a task, Fogg talks of 6 key elements: time, cost, physical effort, brain cycle, social deviance, and non-routine. To give connected solutions the best chance of success, we need to put serious effort into crafting sophisticated user experiences that provide real benefits to users without asking them to do much work. Think of your favourite apps and how easy they make it for you to log in, upload images and connect with your network. So time to sum up. What have we covered? Well, firstly, it's important that we take time to fully understand needs before jumping towards a connected device as our solution. We need to be mindful about what adding sensing and connectivity does to the practicality and cost of our devices. And we need to test early with prototypes to ensure that we can get reliable results. Most importantly, though, we need to be realistic about what we can expect from our users and ensure that we consider their motivation and ability to interact with the solutions that we provide. Thank you.